Reynolds number 1200, gas volume fraction 2%. This is just about as low as I can measure the air. We're at the very bottom of the meter. And we're also almost at the bottom of this meter as well. This air-water combo results in a gas volume fraction of 2% and a Reynolds number of 1200. We can see that the bubbles move a lot faster than the flow of water. See that the flow is completely turbulent. And I will turn the air off. We'll purge some of the bubbles. And we'll go to Reynolds number of 1200, assuming no bubbles. So we see that the flow is still turbulent. And we're unable to measure how much air is going into the system. One reason I think this is turbulent is because the bubbles move faster than the water, and as they brush by the dye, causes turbulence. So there are different velocities. Okay, we see it getting closer to laminar, but it's still turbulent. And at this point, most of the pressure has been released through the wood sparger. Try to get rid of some big bubbles. You can see there's not too many bubbles moving through at this point. Flow's starting to go back to laminar. Well beyond the amount of air that we can measure. We're well under. So we notice when big bubbles pop up, it causes the flow to go turbulent in a burst, but we see that the flow's mostly consistent. There goes a big bubble. Okay, we're starting to go back to laminar now. I will turn the water up to try to purge some of the bubbles and go back down to 1200. I would say that this could be considered the critical point. You can see there's not many bubbles moving through. They're so small, it's difficult to see at this point. So I might call this the critical Reynolds number because we're seeing consistent wiggles, but not complete turbulence. Some complete turbulence up here, but just consistent wiggles. The problem is that I can't measure the gas volume fraction because the bubbles are so small, so little coming out of here that this is registering as 0.